What is up, guys? Welcome to another YouTube video. How is everyone doing? I hope you guys are all doing well. This video is from my basement, guys. Right in the basement, right here in the basement. You can see the pipes up there. We're in the basement. Anyways, before we start anything, I need to tell you guys, you need to smash that like button. Smash that like button. Destroy the like button. I want you to destroy the subscribe button as well. Smash it too. Whatever other synonym of smash there is. Okay? Remember, guys, YouTube has this thing where it unsubscribes you randomly. So I just want you to go down there and check to see if you're still subscribed. Like, why would YouTube do that, right? Just go check. Anyways, today's video is chemistry related. There's nothing cooler than chemistry, specifically thermochemistry, and even more specifically, Hess's law. Okay, so you might be asking, what is Hess's law? Well, Hess's law works because of the conservation of energy. Basically, the enthalpy in a reaction is the same whether it happens over one reaction or a sequence of reactions. Okay, I'm gonna show this next slide. So if our reaction that we want to figure out is A to D, right over here, we want A to D. A to D is the same as going A to B to C to D. Okay, that is going to give us the same enthalpy, guys. That's going to give us the same enthalpy. Okay, basically it's like this. Okay, so going from A to D is the same as going A to B to C and then to D. Okay, that's going to give us the same amount of enthalpy. Okay, why would we want to do this? Maybe, I don't know, we're broke. We can't do A to D. So it's easier for us to do the other reactions. I don't know. I'm broke. All right, next slide. So we're going to do an example. Okay, an example. So this is the reaction we want to figure out the enthalpy for. One carbon reacts with two hydrogens to produce one methane. So these are the reactions that we are given. We are not given the one carbon, two hydrogens to one methane. We're not given that reaction. We're giving the enthalpies of these three reactions. So this is what we got to work with to figure out the enthalpy of the formation of methane. So what we're going to do is first look for the reactants in this. Okay, so let's start off easy. Let's start with the carbon. Okay, now, do we see a carbon anywhere over here? The answer is yes, there is a carbon right here. We have one carbon on the reactant side. That is good. We do not need to do anything for that. It is perfect. We will not touch it. Now, let's look for the other reactant, hydrogen. But guys, there's a bit of a difference here. We have only one hydrogen. We need two. Okay, so what we're gonna do is in this entire reaction, we're gonna multiply everything by 2. So the hydrogen gets multiplied by 2. The oxygen gets multiplied by 2. 1/2 times 2 is 1. The water gets multiplied by 2, and the enthalpy also gets multiplied by 2. Okay, so now that we've found the reactants, we need to find the product. What is the product? 1 methane. Do we see a methane anywhere? The answer is yes, there's a methane right here. But guys, oh no, it is on the reactant side. We cannot have that. So we will multiply by -1 to switch everything. This gets multiplied by -1 as well. The enthalpy gets multiplied by -1. And that is how we do it, guys. After doing all of this multiplication stuff, we will be adding them all up. So here is what it should look like right now. It should look like this. We multiplied everything in the hydrogen reaction by 2, and we multiplied the enthalpy by 2 as well. And over here in the methane reaction, we multiplied by -1. So everything switched over, and this became a positive number. This right here, the enthalpy. Okay. So what we're gonna do now, it's actually a bit weird, but all of the other things that we do not need cancel out. So the 2 oxygens right here cancel out with these 2 oxygens right here. The oxygens on the product side cancel out with the oxygens on the reactant side. Now let's look for more cancellations. There's 2 waters over on the product side and 2 waters on the reactant side. 2 carbon dioxides on the products and 2 carbon. Wait, actually, it is only one carbon dioxide on the product side and 1 carbon dioxide on the reactant side. So we cancel that out. And what we are left with, guys, is 1 carbon right here and 2 hydrogen. And we are left with a methane on the product side, which is exactly what we wanted. So the enthalpy of this is the addition of all of these reactions, which equals to -74.7 kilojoules. This reaction is exothermic, guys. That means it releases energy. Okay, guys, that is the end of the video. I hope you guys all enjoyed. But before you leave, remember to bang that notification bell, because you guys don't want to miss my next video. It's going to be an apology video, guys, an apology video where I rub my forehead the entire time and I apologize for dancing on my granddad's grave for a TikTok, guys. It's an apology video. You don't want to miss it. So remember to hit that notification bell. All right, guys, see you next time. Bye. Peace.